Hello, hello. All right, well, if anyone watched me earlier when I was doing my LeetCode stream, I said I would do these probably like once a day, but I have a really free day today. Just finished lifting, and I thought, hey, why not just get back to it? I mean, I'm having a lot of fun doing this, so I think why wait until tomorrow? Just keep streaming and let me try to hit that goal of 581. So just give me a quick second, gonna have a sip of water, and then we can get started. All right. So in our last stream, we did 9 questions, which I thought was pretty good. Let's write some stuff in the chat here. Welcome one, welcome all. If you follow along with me to hit your goal for the day. All right. You know, even if no one's watching right now, it's just good for me to get in the habit of doing this, of at least typing out these welcome messages. All right, so like I was saying, we did 9 problems in our last stream. I still haven't figured out this one, like build array from permutation. I added it to my list of questions to follow back on. So I probably will at some point. Don't worry, like I'm definitely not going to forget. I have it written down. Excuse me. And also have it saved to my list on LeetCode, so that way I can remember it. So let's go ahead and just keep going through here and let's see what we can do. Cool. All right, this question, yeah, I need to remember to also link to these. So I'm going to link to these in the chat in case anyone also is following along. If, like in case anyone's watching on PC, they can just click the link and follow along with me. This is question 2114. All right, so it says, a sentence is a list of words that are separated by a single space with no leading or trailing spaces. Oh, I think I'm going to have to go for one quick second. Yeah, give me 1 second and I'll be right back. In the meantime, you guys can just read this question. I have to go open the door for my girlfriend. All right. Okay, so most words found. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. You're given an array of strings, sentences, where each sentence's I represents a single sentence. Return the maximum number of words that appear in a single sentence. Okay, each sentence represents a single sentence. These are the bounds. You have 100 sentences. They can each be 100 characters long. So it consists only of lowercase English letters and a space in between only. So it's essentially a valid, like each one of these strings is valid in the sense that we know there's always ever going to be one space in between these. It's probably worth this is like a good thing to ask your interviewer. Always want to check for like leading and trailing spaces. And also if you want to make sure that like in this case we only have one between each. So one thing we could do, we could parse, or actually let's think about this. Maximum number of words that appear in a single sentence. I could loop through each sentence and do a split on the space and then count the length and keep track of that and base my max off of that. So let's say let max or most words equals 0 for const sentence of for const sentence of sentences and do most words equals the math.max of most words or sentence.split at the space dot length. Return most words. Return most words. Let me see how this runs. So 6 and 6, 6 and 3, 6 and 3. Cool. So this runs, this is like decent, but I think we can do better. Oh, this is 91. I'm just curious to see this. Can we just split? Count the spaces of each sentence. Max plus one. Not create temporary strings. So in the split method, do we create a temporary string? How is split implemented? How is string split implemented? Do we have to keep track of like, I guess we do have to keep track of a temporary string or create one at least. So let's do that. Like what if for each one we count the number of spaces? That'll be m times n. So let's see how this works out. Say most words equals 0, and then for const character of sentence, let current most words equals 0. And here we can say if character is equal to a space, we can say current most words plus plus, and then we can say most words equals math.max of most words, or current most words plus 1. 6 and 6. So I mean, is this 8.89? This is seemingly way slower. M by N. Although I would imagine, like, even with the previous solution, it's kind of interesting because I would still expect the time complexity to be roughly the same. If you think about this one, we're still going to have to go through the whole string to split it. Somehow, it seems like this one overall has, well, I guess maybe the performance is about the same, 51. Yeah, I'm pretty happy with this. So I'll say here the time complexity is going to be m times m. So you have m, which is the number of sentences in, or the number of sentences in sentences, if that makes any, the number of sentences, and then n is the number of characters within each sentence. So we have m by n, and that's the time complexity for this, and the space complexity is constant. Although we might consider like any internal space that we use in here, it seems like based on some discussion, we might be using like internally split would have to create a new string or new array based on that, and that might be O of n, trending to O of n. Maybe internally the space complexity is O of n, but at least from what it looks like here, it's constant. Some good things to bring up with like an interviewer, but I'm pretty happy with this. By the way, if this is your first time watching this, I try to do this. Well, this is my second stream for today. I'm gonna try and do these a couple times a week. Again, today's Saturday. I had some extra time, so I figured, hey, I'll just get in a couple streams and have some fun with it. So let's keep going through here, see how much more we can do. Might just shoot for another hour again. Shuffle the array. Let's see. Given the array consisting of two elements in the form, return the array. Okay. 2, 5, 1, 3, and we have 3, so x, x2, x1, y1, two n elements in the form x1, x2, xn, y1, y2, yn. Oh, I see. So 2, 0 plus 3, 2, 3. Okay, so here we really just want to go up until like I minus 3, right? Up until like the 1. So I think what we can do is we can say const shuffled array. We can make this an empty array to begin with, and let's say for let I equals 0, I plus n less than nums.length, I plus plus. Let's do shuffled array dot push nums at I and nums at I plus n. I think that should work. 235,417, 235,417. All the test cases seem to pass. 49.2, 95.5. So see, like, I'm always gonna open the discussions, but I wonder, like, is there, this is like, I'm very happy with this, but let's see if discussions have to say anything. Of course, there's always in place, and I do want to read this one. So time, on some bit, oh, this one's crazy. Just store the numbers in binary representation. This just seems wild. That's right. 1,000. That's crazy. I mean, very good to know. For me, this just seems like a clever thing to understand. Obviously, if you whip something out like this in an interview, you'll look fantastic. I don't think this is typically the expectation. So I'd rather look at something maybe a little more practical. Is this also going to use bitwise? Insane. Store the pair of numbers and then retrieve each number from that pair where they were stored one by one and place them at their desired positions. That's the requirement. This is something I'll definitely want to get to later, but I think for the purposes of the stream and this question, I'm satisfied. So let's move on. The minimum sum of four-digit number after splitting digits. You're given a positive integer num consisting of exactly four digits. Split num into two new integers, nu1 and nu2, by using the digits found in num. Leading zeros are allowed in nu1 and nu2, and all the digits found in num must be used. Return the minimum possible sum of nu1 and nu2. Well, the minimum possible sum will have a, right, there'll be like a, like, how do I explain this? From both, like the most significant digit of both of these numbers will be the lowest digits in this broader number, right? Because that will make it so that it's the, like 2932 to get the smallest number, you pick a 2 and a 2. Like you wouldn't pick a 9 and a 3 because that's already beating the 2 and the 2. So really what we need to do here, we need to get the minimum from all these. What's like an easy way to get a minimum? Like I know of one way that's sort of like shuffling around a lot of numbers, but if I pick one and then I get one that's, yeah, a minimum of two. It's not the prettiest looking thing, but probably storing something like this in a heap would be crazy too. I think that's probably like way too much. We can do this. Yeah, 9999 up to return the minimum possible sum. We can't just like, I can also like convert this to a string. That's not very nice. If we get the two min, yeah, I think really what we'll have to do, well, something that I'll do, I don't think this is like the, definitely not the best way of doing anything here, but we can say min one. This is something I'll try out. Let min one, and I'll copy this a couple times. I'm very curious to see the solution because I want like a nicer way of doing this. Now we can do that trick where we get the digit off the end every time. So we can say something like while num not equal to 0, const digit equals num modulo 10. Now we can sort of do that thing. So min 4. How do I want this to be though? I really want it to be, yeah, I guess what we can do here is we can say if digit is less than or equal to min 4, we want to take the current one. Yeah, we want to say min 3, um, min 3 equals min 4, min 2. No, I'm doing this backwards. I need to be doing, yeah, I think I really need to be doing min 1 equals min 2, min 2 equals min 3, min 3 equals min 4, and min 4 equals digit. Else if digit is less than or equal to min 3, do the opposite thing. Not the opposite, but just like a smaller version of this. Min 1 equals min 2, min 2 equals min 3, min 3 equals digit. Else if, oh man, this is unwieldy. I realize this is not very clear, but I'm going to go for it. Min 2 equals digit. Else min 1 equals digit. So min 1 and min 2 should be the lowest, should be the smallest number. Then over here, I can say num equals math dot floor of num divided by 10. Const digit. Right? Or actually, do we want to, right, okay, no, that's it. Okay, so then we come down here, and now what if we do return min 1, got that pair, oh yeah. Let's see, it's not the greatest, like pair 1 would be min 1 times 10 plus min 3. I'll make these const. There's absolutely got to be a better way to do this. Min 2 times 10 plus min 4. Return pair 1 plus pair 2. Woo! Wow. 124. That's amazing. 1 times 10 plus min 3. All right, let's see what we have here for our numbers. Min 1, min 2, min 3, min 4. 9322, min 1, min 2. Interesting. So really it should be min 4. Let's do min 4, min 2, min 3, min 1, 52, 13, 13, 33%. Not like, definitely not in love with that time complexity. 61, 23. What's like the best way to do this sort of thing? 0 milliseconds. They really sort it? Yeah, I guess two string, they sort it. Yeah, I tried it without string conversion. Digit 4. Yeah, I guess you can do that too. I can just sort in an array. It's a fixed sized array. 2 and 2. Yeah, they just make it a string. Let's, can you sort it just like to string num? Can we actually just, wait, that's not what I want to see. I'm very curious. Let's do const sorted num. Like what happens if I do num dot sort? If I do it a, b, a minus b. Oh, because that's not even, yeah. Let's do this. String num sort. Is it also not like that? Is it because I need to, oh man, trying something different here. 2239. Interesting. Matt? No, this isn't Matt. Guitarist Nate. What's up, guitarist Nate? No, I'm not Matt. My name's Raphael. But hey, maybe you'll see Matt around here sometime. Not on my stream, but like on another stream. That'd be kind of cool. So can we do like if I do return parse int sorted num 0 plus sorted num 1 plus parse int of sorted num. Oh, this should be 1 sorted num 3. I need to make this also pass in the radix here. Let's pass in the radix. Will this work out? 52, 52, 13, 13. It's about the same performance. Like, I guess, yeah, I guess you can do both ways. The the other way I did earlier, I guess it's kind of cool. The thing about the other one that I think is important, maybe it doesn't look very nice. And really, I should probably just put these, I should just put these in an array instead of having them all like this. I think that'll make it a little cleaner. But this sort of like trick right here of picking out individual digits in a number, like saying, oh, getting 2, doing something with that, or storing it elsewhere, and just picking them off from the end is a very useful thing to know. So like definitely recommend for you to at least learn how to do that. Like if this problem showed you anything. Yeah, I think that's definitely like good to know. Cool. So let us get to the next one. Number of good pairs. Oh, this one is a fantastic question. Fantastic question. Let me get some more water. Okay, this is like I forgot how I eventually came to the answer for this one, but given an array of integers, nums, return the number of good pairs. A pair ij is called good if nums I equals nums j, and I is less than j. So like the pair here would be like this one and this one, and then this one and this one, and then we kind of finish there, and then there's no 2, but we have this 3 and this 3, and then we have this one and this one. Now, one of the interesting things to note is like, I guess it's easier to see. Well, we can also think about this before, right? I can say like, okay, when we're at the first one, like I haven't, when I'm at the first one, I haven't seen any ones before. When I'm at 2, I haven't seen any ones before. When I'm at 3, I haven't seen any ones before. when I'm at this one, I have seen a one before, so this is like one pair, right? And then I think when we get, because like if I get here, I've seen one pair also, so that's two pairs. Three, I've seen a three before. Oh, that will be another pair. And then the addition of all these is four, right? Like here I've seen none. Here is my I have seen a one before. Here I've also seen a one before, and we have this one, so now that's two, and then plus this one that gives us the four. And but like we can also do it the other way of like you have a three, and I can sort of store that somewhere. Think about some object like one. Okay, this is like the first time I've seen a one. Two, first time I've seen a two. Three, first time I've seen a three. One, have you seen a one before? Okay, now I've seen two ones. One, and I've seen one before. Yep, I've seen three ones. Three, have I seen three before? Yep, I've seen one. So we can also just like add this to our final, and that will give us the four. But if anything, actually, let me see. I've seen a one. I've seen a one before, so that gives me one pair. Oh, okay, okay. Yeah, we can also do it this way. Like, let's sort of now clear this out. You can think of this like we're here at the eye. We say, have we seen like a one before? No, I haven't seen a one before, but I'll just mark it. Two, have I seen a two before? Nope, but I'll mark it. Three, have I seen a three before? No, but I'll mark it. One, have I seen a one before? Yes, I have. So add this one to the final, and then now increase the amount of ones that we've seen, two. And we get to one. Okay, have I seen one? Yep. I've seen two already, so that's like two different pairs. Add this to that and increase this. Three, have I seen a three? Yep, I have seen a three. So add that three to the final four and then increase this. It's like keeping track of the counts as we go along and then updating it. Like we've seen a one, add to one, okay, and then update how many twos we've seen at that moment. Yeah, I think it's a really, really great problem. So I think for this one, what I wanted to use is like an object literal like this, just to have this is sort of like a way for me to keep frequency of the numbers as I've gone along, and then also this final. So let's see how this works out. Let's say identical pairs equals zero, and then I'll also have let frequency equals my object literal. Now, with this 100, we might be able to actually make it constant space, but let's go for this. So for let I equals 0, I less than nums dot length, I plus plus. So the first time we get to this one, I haven't seen it. So if, let's see, if frequency at nums, let's make it a little bit clearer. Like, do I even need, I don't really need, yeah, I don't need the I can say for const nums of num, if frequency of num is undefined, then set it equal to 1. Frequency num equals at 1. Else, we can say identical pairs plus or equals the frequency at num, and then the frequency at num plus or equals 1. Let's see what this gives us. Return identical pairs. 4, 4, 4, 6, 0. Yeah, this question's like, this is a top tier easy question right here. I would like absolutely focus on this. I would learn this one well. Now, there's a couple, I think there's like one thing we could do better. I guess according to like the way that memory works, if I can set this to be like a static array, it's gonna make it a lot easier for the machine to perform like its optimizations instead of having to worry about this like heap memory for these objects right here. So let's see if we can do that because each of these, like, let's focus on these upper bounds, right? It's only going to be from 1 to 100. So I think let's try something out. Let's make frequency a new array, size 100. We'll fill that with 0. And I think we'll want this to be 101 and fill with 0. And now we can really just do the same thing. So frequency at num. Now if that's equal to 0, that means we haven't seen it yet. Let's think about this. Maybe we don't even need to worry about this anymore, right? Because what if we just update it immediately the first time? Like that might actually just work out. Because like this will be identical pairs. If I just do this like greedily, right? Like this is already 0. What was the problem that we had before? Like this was undefined, which is sort of like 0, so we set it to 1 before we ever did anything to it. But if I just try to be a little greedy and say, well, I'll just add the 0 to 0, it's not going to change anything, and then I'll just update this to 1. That should work out fine. So let's see what happens. 460. Yeah, there you go. I think time-wise, interesting. Well, actually, now I'm curious because that was 42.1. If I go back to my previous 42.3, that is so weird. Like, truthfully, I expected for the time to be better in the second one, only because like I guess we're still able to access these in constant time, but like ahead of time, the computer doesn't know like where. That's one thing that I should probably like look into. Yeah, let's just like give ourselves a refresher on this. Like, how does yeah, see a dictionary over a static array, or maybe just over an array, or do arrays perform better than? I don't even know if you would call this like a hash table, really. Test and results. There's no 100% correct solution. Arrays and objects. Interesting. Differently are arrays of continuous index, objects map arbitrary keys. Oh wow. So do maps even perform better? Okay, let's give that a shot actually. Let's use an ES6 map. So going to what we had before, instead of this, let's do new map. New map if frequency, if not frequency dot has none, and we can set frequency frequency dot set num to 1. Frequency dot set num else equal to identical pairs plus or equals frequency dot get num. Can try this out, and if not, now I'll have to set it, which this is the part that's like kind of annoying. Frequency dot set to num. Let's put this on 2 lines. Frequency set num to frequency dot get num plus 1. So does this work? 460. Still about the same. I mean, at the very least, we're just experimenting with different ways, but objects in the heap versus arrays, stack memory. We can create an array of objects. No, I just want to see. Let's see. Yeah, the allocation happens on continuous blocks of memory, stack memory allocation. No, but I want to see. Stack memory. Stack memory isn't as safe as stack memory allocation. So our JavaScript objects created in heap memory. There you go. This is cool stuff to get into. This is now a little bit maybe out of scope of LeetCode, but since we're here, might as well just like look at a couple of these things. Oh, here we go. Now I want to go back to where we were. Heap and stack, garbage collection. In JavaScript, we create variables, functions, or anything you can think of. Memory for this, okay. Allocating memory, allocate memory, memory heap and stack. Static memory allocation, right? And references, heap, reserve space, stores objects and functions. These objects, instead of more space, we allocate it as needed. Dynamic memory allocation, right? Actual values are still primitive, which is why they're stored in the stack. So the values, so the object itself is stored in the heap, but the values you're pointing to, like these primitives, are also stored in the stack. I'll like link to, let me actually, can I, well, I'll link this in the chat so others can read from it as well. Could be something like cool to learn. I'm gonna leave this open for myself to get to later. But that's neat. Yeah, this question's like really good. Like highly recommend this question. It's you get like a good experience just like going through this whole array, saving things inside of some objects or a map, updating them. I just think it's like a very nice, it's a common pattern you'll find a lot in these questions. So I think it's pretty fun. All right, let's get to the next one. Let me refresh the page. Let's just see like how we've been doing. Okay, so we've done, wow, we've only done 4 questions. You can tell they're getting like a little bit longer now, but that's cool. All right, I think here, okay. You're given strings jewels representing the types of stones that are jewels and stones representing the stones that you have. Each character in stones is a type of stone you have. I want to know how many of the stones you have are also jewels. How many of the stones I have are jewels? What will jewels length? Stone length 50, and stones consist of only English characters, only English letters. All the characters of jewels are unique. So one thing we could do, so I think it's safe to say like if I just want to consider ASCII characters, maybe I can make an array of 256 indices and store all my letters in here. Like one big giveaway here is that this is only English letters. Now because they're uppercase and lowercase, I have to consider all of them. Although wait. Okay, so let's do this. Let's do something like const alphabet, I guess, can be equal to a new array. We'll make this size 256, fill it with 0, and offer each one of our jewels, right? Because we want to know how many stones are jewels. How many of the stones you have are also jewels. So if I store all my jewels, right, then I just need to go through all of my stones and see if it exists in here. So we can do something like for const jewel of jewels. So to be able to get the character code of a character in JavaScript, we can do something like this where we get, I'm going to call this index because that's where I'm going to eventually place it inside this alphabet. We can do jewel.car code at 0, and I'll do minus 97 to normalize it. Although, which one, let's just remind ourselves, which one comes first here? I think it's always the lowercase you want to do, right? Okay, so let's actually do 97. Did I do that? Maybe I should do 65, because if I do 65 minus 97, I'm going to go out of bounds, right? So let's do 65 here. So this is kind of interesting. Like, it literally means if you have an A and you do car code at 0, you're just getting this string's car code at index 0, which is this character right here, and that gives you the numerical code of this, the ASCII value of this character, and then you can do this sort of like math right here to normalize it. Now we should be able to fit it inside of our alphabet. So inside of alphabet index, I'll increase this by 1. Now I can go through, I'll say, how many stones are joules? Let's see, nums, joules, and stones. Stones are 0 for const stone. No, let's not do that. Num stones for const stone of stones. If we're going to do the same thing here, right? We need that index. So const index equals stone dot car code at 0 minus 65. If alphabet at this index equals 1, then our num stones plus or equals 1. Now we can return num stones. 3 and 3, 3, 0, 3, 0, 29.77 for the time, 91.82. So yeah, this is something also that I think is like, so like what are the takeaways here, right? Anytime that you're dealing with string or like strings like this or characters, especially if it ever says you're dealing with lowercase letters or just English letters, lowercase and uppercase, it's normally like check your upper bound, and you can make something like this that's just like a static storage that it's easy to be optimized, right? We already know exactly how much space we're going to need. We create all that space, and we can get to these indices like really quickly. So this is the thing that sort of dominates like space wise. It's really just going to be O of 256 for our space complexity, which just translates to O of 1. It's constant, right? And then for our time, we're going to need to iterate through both joules and stone. So it'll be O of m plus n, where m is the amount of joules and n is the amount of stones. So one key takeaway here again is the ability to create this like static storage where we can put our indices for the different English letters. I picked 256 because we're spanning both uppercase and lowercase. If it was just lowercase letters, I might just choose like 26 just to span the alphabet. And then this other cool like trick I used here, which I found out about a while ago, but I think it's just like a clever way of using it to be able to get the character code of a character in JavaScript. Again, what this translates to, it's like if you have A and you do car code at 0, right? You're gonna get like the car code at 0 of the string, and this string has a length of 1. So like the character at index 0 is A. Apologies for the coughing. So then this will spit out that code for us, and then we can do this math to normalize it so we can fit it into the storage here. So yeah, I think it's pretty neat. I definitely like this question. I think it's pretty cool too. So let's keep it going. Design a parking system. A lot of text. Okay, so design a parking system for a parking lot. The parking lot has three kinds. The parking lot has three kinds of parking spaces: big, medium, and small, with a fixed number of slots for each size. So int big, int medium, and int small initializes object of the parking system class. The number of slots for each parking space are given as part of the constructor. So this is just going to be numbers, right? So it almost makes me feel like I can say something like, oh, my garage is going to have, uh, oh, this is just the number, isn't it? Wait, Checks whether there is a parking space of car type for the car that wants to go. Big, medium, or small, which are represented by 1, 2, and 3 respectively. Okay, so big is going to be 1, 2 is medium, and 3 is small. So the way I got this, because it just says like each of the car types, it's going to be 1, 2, 3, and 1 is big, medium, 2, and small 3. So this just becomes my key, and then we just set it to small. I just want to see some more. Okay, we do have TypeScript. I don't know why I wanted to see if TypeScript existed. I just wanted to see that. So okay, so we have that. Now, if there's no space available, so we're gonna get some car, and we want to see if there's space for it. If there's space, we park it. Okay, so you want to see if there's space. If there is, you return true. So can we do return this dot garage at car type minus minus greater than 0? No, true, true, false, false. Okay, that was pretty simple. Yeah, this one I use this, what is it, like the postfix operator? Is that even how you call it? Prefix and postfix. So this is also like a very cool thing. If you put the minus minus first, it's going to first do this operation. So it'll do the subtraction, then it'll do the condition, then it will evaluate this expression. However, if you do postfix, it will first evaluate the expression and then do the subtraction. So it's like we have a cart, right? Because we don't want to say like you don't go like think about it in real life. Like if you're trying to find a parking space, it's like this is almost like saying, oh, there's an empty parking spot, but I'm gonna subtract a space, which is effectively saying a car is already there, and then I'm gonna try. Like if there's an empty parking spot, you can park there. You don't you don't like say, oh, I can't park here because of this like weird reason. So you can do it this way where you say, okay, is there space available? Yes. So I park and then I subtract. That's kind of how I like to think about it. And then you come here and you get this really nice looking sort of code right here. I think it's fun. We can like make all this stuff real condensed using just like some more modern JavaScript syntax. Like, let me see. I'm a sucker for const. Try to use it wherever I can. So let's do this. We're not returning. Oh, interesting. See that? Oh, this is great because this right here, we want it to be bound to the class, or not the class, but the function, right? So let's leave that like that. This is one of those cases where you're actually going to want to use that. Oof, it didn't like when I removed those comments. Okay, kids with the greatest number of candies. There are n kids with candies. You are given an integer array of candies where each candy's I represents the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. Return a Boolean array result of length n, where result I is true if after giving the ith kid all the extra candies, they will have the greatest number of candies among all the kids, or false otherwise. So kid with the greatest number of candies, number of extra candies that you have. So 5 candies, true. So the kid with the most amount of candies is this one with 5. If I give this person 3, will they have at least 5? Yeah. 3, right? True, true, true. So, okay, we need to first find the max of this whole array. And then if I distribute the candies to each one of these people, yeah, so let's get the max, max candy. Here's a nice little trick too. You can pass in like a comma separated list of numbers to math.max and get the max. So I can just use the spread operator here to get all the different candies. That'll give me the max candies. And then we can effectively do return candies.map candy candy plus extra candies is greater than or equal to max candy. I think this would work. True, 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 false, true. 57.21, 87.26. Yeah, pretty happy with this. So use this spread operator here to be able to pass in. This will effectively take that candies array and just pass in 2, 3, 5, 1, 3, 2, 3, 5, 1, 3. And then max will figure out that 5 is the greatest one. And you can see, because we can run this again, you'll see it'll be the, oh, 2, 3, 5, 1, 3, 2, 3, 5, 1, 3. Did I mess something up here? Why wouldn't that, let's see something here. Let's do some classic. Let candies equals this. Oh, does this not? Oh, wait. Oh, interesting. This is not. Can I just do? That's even worse. False, 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 true, false, true. Does it work if I just do this? Wow. It does work if I do that. True, false, true, true, false, true. Wait, so have I been thinking about this wrong for like a while here? And this just prints out console. Do I also wait. DN max. Give it as input. Value 1, value 2, 0 or more numbers along with the largest value will be selected and returned. Does math.max do? That is so weird. That's just one of those weird things. I need to look more into this, but I could have sworn this like picked off each one of the numbers individually and passed this in as a comma separated list of numbers, but apparently it doesn't seem like that's the case. However, this still works. Really, the main point is we pass in the candies to math.max. It figures out that the max is 5. And then from here, we can use the map to transform the candies array into an array of booleans, where the boolean represents if the candy plus the extra candies that were given as an argument is greater than or equal to the max candy, which is what the question was asking. All right, let's get to this next one. Find a corresponding node of a binary tree and a clone of that tree. Cloned. I think we just have to find original, cloned, and target. These are all tree nodes. I think we just have to find, yeah, we just have to find the target and then return the reference of it in cloned. So this is a binary tree, so it can't take advantage of like any binary search tree properties. So let's imagine like I want to do, I could do, I'm going to do a post order traversal. So I'll start at the 7, go down to the 4, go down to the left, go to the right. So that's one of the base cases, right? So if, let's say if not original, return Let's just return null here. And we get to 7. We go to right, go left, right, left, come up here, left, right, and we're here. So we return 3 because now we found it. So we could say so if original.val equals clone.val return cloned, and here we can do return get target copy of original dot left clone dot left target. No, wait. Original dot val equals target dot val, right? Because these are all tree nodes. Target or get target copy original dot right cloned dot right and target. What does this give us? 33374 86.86. Oh, that's a nice number. Now I'm thinking though, like, I mean, could it be faster? I guess either. Is it good to do DFS or BFS? If we do DFS O of n, O of n, O of n, O of n, BFS iterative O of n, this is not even a question. Even the follow-up should be, what's the follow-up? Could you solve the problem if repeated values on the tree are allowed? I wish they would. Wait, could you solve the problem if repeated values on the tree are allowed? I mean, we'd always know if it was a reference to the original one, no? Like, two binary trees, original and cloned, and given a reference to a node target in the original tree. Clone tree is the copy of the original tree. Return reference to the same node. So your reference, the answer must be a reference to a node. Would you just always have a reference to the original one that you can reference and get your answer? You might be thinking of that differently, but all right, let's keep going here. Probably we'll just do like one more question. I have about 3 minutes left. I normally like to try and keep these like to an hour for now, but we'll keep going. Subtract the product and sum of digits of an integer. Okay. Let product equals 1, because we're going to be multiplying. We can make our sum 0. We can say, well, n is not equal to 0. Const digits is n modulo 10. Product times equals digit. Sum plus or equals digit. N equals math.floor of n divided by 10. Return product minus sum. I think that's what they want. 15, 15, 21, 21, 96.61. Again, very similar to this first thing here. So like this process right here of picking out individual digits and being able to operate on each one of them and do something with them is very helpful. It's something that you'll see many, many times. So like just highly encourage you to check that out. Make sure you truly understand that pattern. And with that, I just want to quickly, like, very quick plug is this is I'm doing these streams like mostly for myself to keep myself accountable and hopefully keep a lot of you accountable as well. Anyone watching, I'm gonna go ahead and upload this to YouTube. I guess I don't really have like, I I should probably come up with like a better channel name or something like this, but this is just my personal channel where I'm uploading this. So yeah, if you want to look at this one and previous ones, I'll be uploading these just for posterity. Hope to see you guys more often. I'll be sure to keep making these streams. I'm having a lot of fun with them. And if you guys are having a lot of fun with them as well, let me know and we'll have a lot of fun. So thanks for watching, everyone, and you guys take it easy.